I've picked out a problem that I've worked out earlier in the year with 3 variables and 3 equations, and I just want to talk you through how to solve it. You need to pick one equation out of the 3 and solve for one of the variables. Now this is totally up to you as to which variable you want to solve for and in which equation you want to do it in. My advice would be to pick the simplest equation that you can get to a single variable. Now the top equation happens to be the easiest one to solve for one of the variables. I just happened to choose solve for x. I could have just as easily solved for y or z. So I picked x. Once you've picked that equation and solved for the variable, you're going to substitute that back into the other 2 equations. So you can see I've highlighted in red, I've taken the x out of the second equation and replaced it with that 110,000 minus y minus z. Everything else is the same in the problem, and then I went to the third equation rather, and did the same thing. Where I see x, I replace it with the 110,000 minus y minus z. And I've done that here in this second brace. From here, you want to remove the parentheses by distributing. Now the numbers get a little chunky, but you can go ahead and use a calculator if you need to. Ultimately, you are now going to have an equation that has only 2 variables in it. In this case, it'll be y and z. And the second equation here is going to have variables of y and z only. So after I've distributed, I need to ultimately collect all the variable terms on one side and the constants on the other. So that's what I've got here listed. Combine like terms, move variables to one or to the left and constants to the right. So this is what I get in the next line. And you can see that, if I add the 0.09y and the negative 0.07y, that's where I'm getting the 0.02y. So all I did was combine like terms, move the constant to the right. On the other one, I moved the y's and the z's to the left and the constants to the right. Now I can go back to my method of solving a system of 2 equations with 2 variables. You can either do this by the elimination or the addition method, or you can use substitution. Now this one lends itself to the elimination of the y terms, because if I add the 2 equations up, the y's drop. And I'm left with now just an equation in z. So I solve for z by dividing both sides by 0.22 and come up with z equals 50,000. Once you have one of the variables, now you start doing your back substitution, which means you take the z value that you found and plug it back into either of the 2 above equations and solve for y. I chose the top equation and substituted out the z for 50,000. And now I have an equation in just y that I can solve for. So in solving for y, I got 40,000. So now I have 2 of the variables, z and y. I can now substitute back into an equation that has both x, y, and z in it and solve for x. So I went back to the one that I had solved for x, put in my 40,000 and my 50,000 to solve for x. And those are the 3 values. X is 20,000, y is 40,000, z is 50,000.